Hello everyone, welcome to my YouTube channel. And due to the lack of resources and on the other hand I like saving things, I will be using the same page from the other side. That was our last lesson, as you know, powers of 2 and their allocation inside class A and B and C. Right, let's move on to the next one. I mean, I can share powers of 2 again, but really what I really want you to do is understand the logic behind what we are doing. So we are actually doing subnetting, and if I write, we are doing subnetting, sub N-E-T-T, yeah. Then we are finding the ranges, and once we do subnetting and find the ranges, we need to allocate them in our network. Allocate to networks. Simple as that. So we do subnetting, as we are doing here, learning the logic. We'll be doing subnetting, and after we find the range, we find the specific ranges and allocate to networks. So allocate to networks is a part which we are not doing at the moment. It is called VLSM, variable length subnet masking, which furthermore includes classful and classless addressing. We'll be doing that later, but that's more of a slightly higher logic. We are actually in this phase at the moment. So let's carry on. So now our new solution that we have to find is, first it's a question, is we have to find a subnet mask. Subnet mask which will, or which we have to use for this particular subnet or IP address. So let's, guys and girls, 172 is class B. Thank you. Right, that's our particular address that we have. So we have to find out the subnet mask. And furthermore, that's subnet or IP address that we have got. We have to find the subnet mask. Furthermore, it says to us that we have to get where we have to get, or where we can get, 2,260 subnets. 2,260 subnets. Yeah, so that's our IP address here. And we can call it a network as well. So what we need to achieve is we have to get 2,260 subnets, and what we need to do furthermore is we need 10 hosts per subnet. Do not panic. Do not panic. We'll be all right. Yeah, it's just once you start doing practice, you will know what you're doing. So in order to save the page, as always, we move on to this site. Now, so first let me have a guess. So what we are doing actually is we have to find out a subnet mask in this network that can give us 2,260 subnets and 10 hosts per subnet. So as you all know, even if you don't know, it's fine. Watch my previous videos. And if you have some logic of class B subnetting, we usually work in the third and the fourth octet. Correct? So yes. So third and the fourth octet. Now if I see this network that has been given to us, 172.30.0.0, so we have to start analyzing in a sense that what sort of subnet mask we'll be using, so that we'll be moving forward into this area. So let me just think. So if I do, so if we are in the third octet, in which we have 8 bits, as you all know, so I'm going to toggle or change 0 to a 1 here, first bit. So that's, as we all know, that's 2 power 1, that's 2 power 2, 2 power 3. So I'm changing the zeros to 1, 2 power 4. Yeah, so once we get to 2 power 4, I'm going to start analyzing what furthermore can be done. So as you all know, that 2 power 8, 4, 5, 6, 7, 8, 2 power 8 is 256, fine. Yeah, but what we really need is 2260. So what we'll do is we'll carry on changing. So that's going to be 2 power 9, 2 power 10, 2 power 11, 2 power 12. So just analyzing and seeing. It's just about analyzing and seeing what can you get in a sense. So 2 power 8 till here is 256. So we can't use, really, we need 2260. So there is no way that that's going closer. So 2 power 9, that is why power of 2s are so important. So that's 2 power 9, 2 power 10, 2 power 11. So what is 2 power 12? So 2 power 10 is 1024, correct? Now 2 power 11 is 2048. We're getting closer. So, and furthermore, I'm just having a quick revision myself as well, because sometimes I keep on forgetting them. So now see, 2 power 12, yeah, so that's 8, 9, 10, 11, 12. So 2 power 12 is 4096. Correct? Now we needed 2260 subnets. So once we carry on changing those bits or toggling them, changing them from 0 to 1 in the third octet here to here. So that comes up to 2 power 12. Yeah, correct? Now, so what I'm going to do is I'm going to start analyzing the table values now. So what do I mean by table values? So I'm just going to show you what table values are. So as you know, we are in the fourth octet here. So table values are actually this. 1, 2, 3, 4. First value is always 128. Second is 192. Third is 224. Always remember, guys, always it will stay 224. So we are here, 2 power 9, like that. 2 power 10, like here. 2 power 10 is 192, table value. And then we have 2 power, so till here, 2 power 8, 2 power 9. Do you understand what I'm saying? If even if you don't, just carry on watching videos, you will understand. Right, that's 2 power 8. So we have extended from the third octet to the fourth octet to find our subnet mask, which we'll be looking at. So 2 power 9, 2 power 10, 2 power 11, so 2 power 12. We have gone to 2 power 12 here. And the table values, as we all know, for 2 power 9 here is 128. 2 power 10 is 192. 2 power 11, as we see here, is 224. And 2 power 12 is 240. So this is 240. Just focus in your mind regarding that. Now, let's move on to the next part. So we have managed to achieve this 2260 subnets. Because 2 power 12 is 4096. So with this sort of, if with 240, in here as a table value, we have achieved this. Now we need to achieve the next part, and that's 10 hosts per subnet. So 10 hosts per subnet. So as everyone knows, in order to get subnets or hosts per subnet, particularly we use this formula 2y minus 2. So as you see here, only 4 zeros as there is 8 values. So these 4 bits are left, and zeros, we'll add them up. So 2, 1, 2, 3, 4. So 2 power 4 minus 2. As we all know that 2 power 4 is what? 16. Thank you. 2 power 2 is 4, 2 power 3 is 8, and 2 power 4 is 16. So 2 to the power y, which is 4. So how does that 4 can come in? The 4 zeros that are left here, we will be using them to find our 10 hosts per subnet. So once we subtract 4 from 16, we get what? We get 12. Good. So as we all know, now this is achieved as well. But what is really the answer? So we have achieved both of these because of changing all the bits and going into octet number 4, where the table value is 240. So as we all know, what's the default subnet mask for class B? Sorry, my hand is shaking a bit. I've done more exercise today, so that is why it's happening. Kindly everyone, come back, concentrate. Frauds, concentrate. What? No. Sorry, the video has gone a bit longer, but we are very close to solving this now. So the default subnet mask is always 255. Yeah, because I think the camera's vision is getting a bit. Default subnet mask is always 255.255.0.0. That's the default subnet mask for class B. But in this case, as you all know, that we have moved forward to, and all the bits have gone to 1. So when all the bits are 1, 1, 1, 1, 1, 1, 1, that's 255. 255.255.255, as we see here. Just carry on watching it, you will understand what I mean. Now, as you know, the table value was what in the 4th octet? 240. So we'll put 240 here, and that's our answer. Simple as that. So what happened here actually? That's the default subnet mask. They wanted us to find a subnet mask where the requirements were we have to get 2,260 subnets, and we have to get 10 hosts per subnet. So we can only achieve this by going into the IP address and working our way through the 3rd octet, where we knew that 2 power 8 cannot, I repeat, cannot make 2,260 subnets. It can only make how many subnets? 2 power 8 is anyone, 256 subnets. So we have to move forward here in order to see whether we can nail it. So 2 power 12, so 2 power 9, carrying on forward from there, 2 power 9, 2 power 10, 2 power 11, 2 power 12. So 2 power 12 is 4096, which is achievable with this one. And we actually got 4096 subnets. So this is covered in that. So furthermore, in the 4th octet, we had 4 bits left, and we have to use them to get 10 hosts per subnet. So we use the formula for 2y minus 2, 2 to the power 4 minus 2, and we got 12 here. So both of these things were done. Then again, what we really needed to do was to get the default subnet mask for class B, which is this one. And from here, we'll do the same thing. So we'll check 3rd octet, which was here, this one. So we had to change all the zeros to 1 to find our subnets. So when we change all the zeros to 1, the value comes to 255. So that's the third octet. And then the table value, as I told you before, first one was 128. That's the fourth octet, this one. And second is 192, then 224, then 240. So that 240 we had to copy here. So with this subnet mask that we have, we can achieve all this. Now, we can allocate these in a network, literally. So we have these many subnets, and in those subnets, we have 12 hosts per subnet. And similarly, that obviously, as I said to you, VLSM is the one where we usually do it, which we are not doing it at the moment. We are staying at this phase at the moment. So just to let you know, our answer, the subnet mask, or the subnet mask that we needed to use with this particular IP address is this. Now, focus, relax, and focus. As you all know, this is a class B IP address, and this is a class C mask. So you understand me? Usually, we use class B masks with class B. But in order to see what our network requirements are, our requirements of the network, we can use class C network mask, which is this one. And I repeat, this is not class B network mask. This is class C subnet mask that we have used with class B here. So just to cut it short, this is our answer. And I repeat, this is a class C subnet mask. 255.255.255.240. And in this solution, or in this problem, we have used it with class B IP address, which is this one, to achieve 2260 subnets, which furthermore contains 10 hosts per subnet, only with using class C subnet mask and class B IP address combination. So we have got different ways of using it. So I'll see you in the next video. Please watch it thoroughly, slowly. If you don't understand anything, watch it again and again so that you get the true logic of this video. I'll see you in the next video, and we'll carry on with our series of subnetting. And I might add some network fundamental videos as well, just in order to do network exams, or if you are working as an engineer, rollout engineer, or you are teaching somewhere, or you are teaching kids, or you do private tuition, or you just do your own learning bits and pieces. Whatever you want to do, we'll carry on with this. Bye, see you later.